Hey everyone, this is Remy, and this video is going to cover the Math 124 note outlines for Chapter 3, Section 5, Solving Equations and Inequalities with Absolute Value. So we've done equations and we've done inequalities, and now we're also incorporating absolute value as well. So first, we're going to solve equations that have absolute values within them. So for a greater than 0 and an algebraic expression, which we'll just call x, then if you have the absolute value of that algebraic expression and it equals the number a, then that's equivalent to taking the expression and setting it equal to negative a, or taking the expression and setting it to a itself. And then whenever you're solving an equation like this with absolute value, make sure that you isolate the absolute value first. Okay, so solving this one, part A, we have the absolute value of x equals 4.9. So what we're going to do is take that absolute value, or the argument of the absolute value, which is just x, set it equal to what's there, which is 4.9. Or we'll take the inside part of that and set it equal to negative 4.9. And then those would be our two solutions. And if you plug them back in to the original, it makes the whole equation true because the absolute value of 4.9 is 4.9 and the absolute value of negative 4.9 is 4.9. So they're both good solutions. Part B, remember we're always supposed to isolate the absolute value first. It's not isolated right now. So what could we do to get that absolute value part by itself? We would subtract 3 from both sides. So I get absolute value of x equals 1 minus 3, which is negative 2. But at this point, you should take a step back and think about what this is saying. The absolute value of something turns out to equal negative 2. Well, that's not possible. You can't take the absolute value of something and have it equal a negative number. So we'd write no solution, because absolute value is never negative. So there's no number that you could plug in for x and make this equation true. Okay. Alright, again we have another one that where the absolute value is not isolated, so before we begin, got to get that absolute value part by itself. So first thing we could do is what? Let's get rid of this minus 6 somehow. How can we get rid of a minus 6? We'd add 6 to both sides. If I add 6, I get 11. Okay, now what? Now we need to actually get rid of this 3, because if this 3 is gone, the absolute value is isolated, and then we can go ahead and use our rule. Do not distribute the 3. It doesn't work that way across absolute value. Okay, so we're not allowed to just distribute the 3, but we can get rid of it because this is 3 times the absolute value of something, and so we want to undo that by dividing both sides by 3. In which case we'd get absolute value of 3 equals 11/3. Okay, now the absolute value is by itself, so what we can do is write the inside part of it, x plus 3, equals that number, or x plus 3 equals the negative version of it. So splitting it up into two cases like that once the absolute value is isolated. Now it's just kind of a larger version of what we started off with in part A. Alright, and now of course our goal is always to get the variable by itself. So to get rid of this plus 3, subtract 3 from both sides. And then this is x equals 11/3 minus 3 is 9/3. So we get x equals 2/3. And then over here, again, we need to get rid of that plus 3, so we will subtract 3. So we have a negative 11/3 minus 9/3, and that is x equals negative 20/3. So we have two solutions. And if you do plug 2/3 into this original and solve it, and simplify, and also negative 20/3, no matter which one you plug in to this and simplify, it will make this whole equation true. So they're both good solutions. Okay, and then part D is the absolute value isolated right now. It's not because we have this minus out in front. So to get rid of this minus, we'll multiply or divide both sides by -1. So if I divide this side by -1, now we're just left with that absolute value equals -4 divided by -1 is +4. And now we have the absolute value by itself, so we can take it out of the absolute value, set it equal to that number, or take what's inside the absolute value and set it equal to negative that number. And then solve each of these. So to get this x by itself, we'd add 9. So we get 2x equals 13, and then divide both sides by 2, get 13/2. And then for this case, add the 9 over, we get 5, divide by 2, we get 5/2. And that would be our other answer. And again, if we check both of these, they do make the equation true. So these are good solutions. So for the most part, anytime you have an absolute value equals something and the absolute value is isolated, once you're at that isolated point, you split it into two cases. You set it equal to the original value, or you set that inside part equal to the negative version of that value, and then solve. Okay, so that is solving equations with absolute value. And now we will solve inequalities that have absolute value, so less than, greater than, stuff like that. So for a greater than 0, and an algebraic expression x, you have absolute value of x is less than some number a, then that's going to be equivalent to negative a is less than x is less than a. And then the other one I'm going to do in a different color just to set it apart. So if you have instead that the absolute value of x is greater than a, then what it's going to be equivalent to is x is bigger than, x is less than negative a, or x is bigger than a. So when you have the absolute value less than some number, then you just put it into one longer compound inequality like this. But if you have the absolute value bigger than the number, then you split it apart and set one of them less than negative a, or the original one bigger than a. And then this same type of rules apply if you have the less than or equal to symbol, greater than or equal to. So x, the absolute value of x is less than or equal to a, that's going to be like this first one. So then you'd have negative a is less than or equal to x, which is less than or equal to a. So you just put it into one long compound inequality. And then if you have absolute value of x is greater than or equal to a, then that's going to be like this one. then x is less than or equal to negative a, or x is greater than just a. So you have to remember which one to do based off of the less than or the greater than. Alright, so we're going to solve these inequalities, and they all involve absolute value, so we have to use these rules here. And then it says if there is a solution, write your solution in interval notation. So we're going to do that once we solve it, and also graph. So we need to do 3 things: solve it, write that solution in interval notation, and then also graph it. But it says otherwise state no solution. So if there is no solution, we're just going to write no solution. So let's go ahead and solve these. I think that anytime it's this case where you have the less than, I'll do it in that same color. Okay, so that's like part A. We have the absolute value of something is less than or equal to 10, so that's going to be one of these, and it's going to be this one here, because we have less than or equal to. So in this case, what we're supposed to do is we have this number 10, we make it negative 10, and then less than or equal to y, and less than or equal to this positive 10. And then always the goal is to get the variable by itself, and the y is by itself. So we're done solving. Now we need to write it in interval notation. And this is saying that we have everything between negative 10 and 10, and then we use a bracket because of the equal part. So that's our solution in interval notation. And then graph, we know it starts at negative 10, goes up to 10, and then do we have open or closed circles? We have closed because it's bracket, and then we gotta kind of shade everything in between. Everything from negative 10 up to positive 10. And this answer makes sense because any number that you choose in this range of numbers, if you take the absolute value of any number in here, then it will be less than or equal to 10. So say you choose negative 2 right here. Well, the absolute value of negative 2 is 2, which is less than or equal to 10. And you can check that for all of these. And then if you check some that are outside, then it's not going to work. So if you choose like 12, the absolute value of 12 is 12. That's not less than or equal to 10. So this makes sense. All right, now we have one that's greater than. So in this case, it's going to be one of these. This one or this one. And it's this one. So absolute value of x is greater than a is equivalent to this or this. So we have to split it into 2. So we're going to take that inside part, which is x, and we're going to make it less than the negative version of the 3. Or we take x and just make it greater than 3. And the x is by itself here, and it's by itself here, so we're basically done solving. So now we have to write it in interval notation. So for something to be less than negative 3, that means everything from negative infinity up to negative 3. And then we need to decide if we want open or closed, less than, so open. And then or, so we're going to put union, x is bigger than 3, meaning we want to start at 3 and go all the way up to infinity. And then on a graph, on a number line, these are our values, and we want everything that's less than this number. So we shade this way, put an open circle, or we want everything that's bigger than the number 3, and an open circle. So that would be our graph. Okay. All right, moving on to part C. Again, this is kind of like when we had on the previous page. Think about what this is saying. We have the absolute value of something, and that is going to be less than negative 7. Can that ever happen? Can you ever take the absolute value and then it gives you a number that's smaller than -7? That can't happen. So we're going to write no, oh, I guess so. So we're going to write no solution. And that's because the absolute value is never negative, so there's no way that it's going to come out to be smaller than -7. Okay. And then what about this one? Think about what this is saying. We have the absolute value of something, and we want the absolute value to be bigger than or equal to the number 0. Well, no matter what you take the absolute value of, isn't it always going to be bigger than 0 or equal to 0, no matter what number you put in there? So, in this case, we're going to say that x, this variable, can be any real number. Because and you can even try it. Think of any number you want, plug it in here. No matter which number you choose, once you simplify, this part will always come out to be bigger than or equal to 0. And then in interval notation, that's everything from -infinity up to infinity. And then if you wanted to graph it, you could basically just shade your whole graph. Okay, and for that one we could write, this is because the absolute value is always greater than or equal to 0. Okay. Do a few more. Okay, so this time we have a greater than or equal to 7, so let's see which one that's going to be. So that's like one of these. So it's this case here. So we have to split it into 2 with the or in between. So we take it out of the absolute value, just 2x minus 5, and then we make it less than or equal to the negative version. Or you take 2x minus 5 and make it greater than or equal to just the original 7. And then we solve each of those on its own. So this time x is not by itself. We need to get this x by itself. So I'll add 5. So 2x is less than or equal to -2. And then divide both sides by 2. So we get that. And then for this one, add 5, we get 12. Divide both sides by 2, we get 6. So as far as interval notation goes, this is saying x is less than or equal to -1. So that's everything from -infinity up to -1. And then do we want open or closed? Closed. And then also this one. So union. Now this says x is bigger than or equal to 6, so we want to start at 6 and then keep going from there up to infinity. So that's interval notation. And then the graph, we have -1 and 6. We want everything, well, first of all, -1 and 6, we put closed circles, and then we want everything less than -1, and we also want everything bigger than 6. Now we have a less than or equal to, so when you have that, you take the expression out of the absolute value, so x over 5, and then we put it into one big compound one. We put -8 over here and +8 here. And then we solve this all at once. We want to get this x by itself, so what's preventing that from happening right now? The x is divided by 5. So how do we undo divided by 5? we need to multiply both sides by 5, or I guess all three parts by 5. If we multiply negative 8 by 5, we get negative 40, less than or equal to. If we multiply this inside part by 5, they cancel, we get x, less than or equal to 8 times 5 is 40. And now this x is by itself, so now we can put this in interval notation. This is saying the numbers that we want are between negative 40 and 40. So we will start at negative 40 up to 40. And we have brackets because of the equals. So that's our interval notation. And then number line, we can just say here's negative 40, here's 40. We want closed, closed, and shade in between. Okay, and part, E, F, this should be G. This is H. Okay, so for part G, we have another less than, which means it's like F. We're just going to put it in one long compound one. So first thing, we can just remove the absolute value part, and when we do that, we need to create one big compound inequality, and we're going to have minus 3 over here and plus 3 over here. And now the rest is getting that x by itself. So right now we have negative 2x plus 5 over 6. So to get rid of this over 6, let's multiply all three of these parts by 6. If we do that, we get negative 18 less than, inside here we'll just be left with the numerator, less than positive 18. Now what do we want to get rid of? We have a plus 5, let's get rid of that. We can subtract 5, so we get negative 23 here, negative 2x by itself now, less than 18 minus 5 is 13. Okay, now the x is almost by itself. What do we get rid of? We need to get rid of this negative 2. This is being multiplied to x. So to undo it, we divide both sides by that negative 2. But be really careful. Remember inequality rules. We just decided that we need to divide by a negative number. So when you multiply or divide by a negative number and you're solving an inequality, what do you have to do with these? You have to reverse these symbols. So I need to go like that. Negative 23 divided by negative 2 is positive 23 over 2. And then negative 2x divided by negative 2 is just x. And then here we have 13 divided by negative 2. So that will just look like that. 13 over negative 2 is going to be negative, so negative 13 over 2. And now, I highly suggest that when you have something like this, always write it from smallest to largest. Well, negative 13 halves is smaller than 23 halves. So to get everything kind of in the right order, we'll just kind of flip everything like this. It still means the same thing, but now we have smallest to largest, left to right. And that helps us when we go to do our interval notation, because interval notation also has to be smallest to largest, left to right. So we're going to start at negative 13 halves up to everything between negative 13 halves up to 23 halves. And then open or closed. We're going to put parentheses. So that's our interval notation. And then on a graph, negative 13 halves is here, 23 halves is here, and open, open, and we want everything in between those two. Okay. So this is saying that any number that you choose from here up to here, and that you plug into this, it will make this whole thing true. But if you choose like negative 13 halves or 23 halves, it won't make it strictly less than 3. Okay, and let's do one last one. Okay, so this time I see that the absolute value is going to be bigger than the number that's over here. So that's the other case. That's going to be like E, because E was, the absolute value is greater than the number. We're going to end up with that at some point here. So remember, isolate absolute value first. So the first thing we'll do is add that this 3/5 over. Then I'll get 2/3 x plus 3 is greater than, we'll have 3/5 plus the 3/5, so we get 6/5. Now the absolute value is by itself, so now we can use the rule, split it apart. So we're going to write it without the absolute value, and then the first thing we write is that it's going to be less than the negative version of that number, or we write that it is just bigger than that number there, 6/5. And now we'll just solve it. And so at this point, if you see this, you say, okay, at least the first thing I think is, oh, I need to get rid of that 3. So you could subtract 3 if you want. That's perfectly fine. But I'm just going to get rid of the denominators. And so I need to find my least common denominator, 3 and 5. So the LCD is going to be 15. And we can multiply both sides by 15 then. And that's okay because 15 is not negative, so it's not like we don't have to switch the inequality symbol or anything like that. We're allowed to multiply by 15. And then we distribute that. 15 times 2/3 is going to end up to be 10, and then x plus 15 times 3 is 45. And then over here, if you multiply these two numbers together, negative 6/5 times 15, you are going to get 15 over 5 is 3 times negative 6 is negative 18. And now the fractions are gone. Subtract the 45 from both sides. We'll get negative 18 minus 45 is negative 63. And then lastly, divide both sides by 10. And we're dividing by positive 10, so we don't have to reverse the sign. Now let's do the other one. LCD is 15 over here as well, so multiply both sides by that to get rid of the fractions. If I distribute this, I'm just going to get the same thing as over here. So we're going to get 10x plus 45 is greater than, but here it's the same thing but positive, so we're going to get 18. And then when we subtract the 45, 18 minus 45 in this case is negative 27. And then divide both sides by 10, get negative 27 over 10. So these are our solutions. Then in interval notation, we have everything less than negative 63/10. So that's negative infinity up to negative 63/10. Union this one, everything bigger than negative 27/10. So negative 27/10 up to infinity. And remember, for interval notation, always has to be smallest to largest, left to right. So is that the case? Negative infinity up to negative 63/10. And then negative 27/10 is larger than negative 63/10, so we're good up to positive infinity. And then interval notation, or sorry, graphing. Here's our number negative 63/10. Here's negative 27/10. Open, open, everything less than that one, and everything bigger than that one. Alright, so that concludes the section 3.5 note outlines.